Hey guys, in this video, let us understand Spark Declarative Pipeline (SDP). It is introduced in Spark 4.1.1. It is a declarative framework for building reliable, maintainable, and testable data pipeline. Here you can refer the Spark official documentation. What is Spark Declarative Pipeline? Spark Declarative Pipeline is a declarative framework for building reliable, maintainable, and testable data pipeline on Spark. We focus on transformations. Spark Declarative Pipeline SDP handles orchestration, compute, management, and error handling automatically. What are the supported use cases? We can ingest data from n number of cloud storages like S3, ADLS, N2, GCP. We can ingest streaming data also by using Kafka, Kinesis, PubSub, Event Hub. We also do transformations on incremental batch and stream transformations. How to install Spark Declarative Pipeline? Pip install Spark and a pipeline name. What are the key design patterns? Define what tables should exist and what their contents should be. SDB handles the orchestration, compute management, and error handling automatically. Key concepts: flows, datasets, and pipelines. Flow, the fundamental processing concept. A flow read data from source, apply user-defined logic, and write the result to the target dataset. Support both batch and stream processing. How we can create a flow? Create streaming table and target as select star from streaming table source table. Here source table is a source data type and target is a destination. When it comes to materialized view, a view pre-computed into the table always has a exactly one batch flow writing to it, best for aggregation or joining on the stable data. How to create materialized view? We have some annotations at the DP materialized view on a UDF, on a function, on a Python function. Here we created a def. It is a method name basic underscore mv. It's written the spark dot table and it is a table name. When it comes to pipeline, the primary unit of development and execution. A pipeline contains flow, streaming data, materialized view. HDB auto orchestrate execution order and parallelism. This is a code we mostly placed in the Spark pipeline.yaml file. Here we mention my pipeline name. You can mention your pipeline name. And when it comes to the library, under the library section we have global include pipelines. It is having what are the Python files present in the pipeline. It will automatically consider as a pipeline. When it comes to streaming table, a table definition with one or more streaming flows working into it. Support incremental processing. Only new data is processed as arrived. How to create a streaming table? Here is a sample code. At the dp dot table. Define it is a Python method or UDF. Def basic underscore st. Return spark dot read stream dot table. Here is a table reference. When it comes to temporary view, scope to a single pipeline execution, useful for incremental transformations that multiple pipeline elements depends on, cannot be read outside the pipeline. What is the difference between materialized view and temporary view? Materialized view, the value stores into the memory. When it comes to temporary view, The results are not stored. The scope specific to the single pipeline execution only. How to create a temporary view? Here is a sample code. /dp temporary view def. I created a staging method. It will return spark.table.raw data. And the final key concept is pipeline project. A set of .py or .sql source file plus a YAML specific like spark hyphen pipeline.yaml file. This specific defines library path, storage, catalog, database, and Spark configuration. In the Spark project, we have catalog name, and database, which database it will refer, and storage, what type of storage it is, checkpoint, and configuration like spark.sql.sepal partition. Here I mentioned 1000. The Spark pipeline command line interface. The Spark pipeline is built on top of Spark Submit and support all cluster management. The primary subcommands Spark pipelines init. It will generate a pipeline project with the default configuration and the directory structures. Here, how to create a Spark pipeline by using Spark init. Here is a sample command: Spark pipeline space init --- name. Here I mentioned my pipeline as my pipeline name. When it comes to Spark pipeline run, it will run Spark pipelines, launch pipeline execution, and monitor the progress until completion. -- specific to select the pipeline YAML. It not provide search or current and parent directory for spark -pipeline.yaml file. Here is a command for run specific pipeline and cluster manager. Here I use yar spark pipeline -pipeline run -- specific. Here I try to run spark pipeline.yaml file and master is yan. Spark pipeline dry run. Validate the pipeline without reading and writing data. Catches. It will catch as syntactical error, invalid Python or SQL, analysis the error, missing table columns, graph validation error, cyclic dependency. Here is a command: spark -pipeline dry run, and here I -- specific and spark pipeline.yaml file. Materialized view. Here we have a syntax to create a materialized view. Create materialized view basic_view as select star from. Here is a 3-level namespace, and here is a table name. When it comes to temporary view, here is the syntax to create a temporary view. Create a temporary view basic_mv as select star from samples, syntax and trips. Here is a syntax to create a streaming table. Streaming keyword equal to streaming semantics. Create streaming table basic_st as select star from streaming sample site taxi trips. Multiflow to one target. Create streaming table customer_us. Create flow append one as. Here is a flow name as insert into customer_es. Select star from stream customer underscore us underscore west. Create flow append to as insert into customer underscore us, select star from string customer underscore us underscore east. Here we created a two append flows, append flow 1 and append flow 2. What are the limitations in SQL? In HDP, the pivot clause is not supported. Here is a way to create a HDP in Python core patterns. And before that one, we need to import pipelines from PySpark. Import pipeline as DP. Here is a way to create a materialized view. Here we use @dp dot materialized view, and here is a basic MV nothing but materialized view. It will return spark dot table, and here is a 3-level namespace, and trips is a table with custom name. If you want to create a materialized view with our own name, we can create by using name equal to and trips underscore MV. If we haven't mentioned a specific name, it will take method name as a materializer view name. When it comes to temporary view, @dp.temporary view, here is a staging underscore TV nothing but temporary view, return spark dot table, and here is the names 3-level namespace, and trips is a table. Scope to the pipeline runs only, cannot be read externally. When it comes to streaming table, @dp.table, here is a method name basic underscore streaming table st, return spark dot read stream dot table trips. If you want to read data from Kafka source, Kafka topic, we can use @dp.table def from underscore Kafka, return spark dot read stream dot format Kafka, option subscribe orders dot load. When it comes to multi-flow to single target, here we created the two append flows, append flow 1 and append flow 2. It will read data from customers underscore us west. It will read data from customers underscore us underscore east. Here we created the target string table, customer underscore us. It will inject the data into the customers underscore us. Querying pipeline table chain transformations. Table defined in a pipeline can refer each other. HDP resolve the execution order automatically. Here we have two sources. One is Kafka source and one is CSV source. Here we use streaming table, and here we use materialized view. And the customer underscore orders, it is a materialized view. We joining orders and customers. When it comes to the final stage, daily underscore orders underscore by underscore state, it is a materialized view. Grouping by state and order date. Here how we programmatically approach this above pipeline. Here we created a streaming table by using Kafka. Here we mentioned topic as format as Kafka, and bootstrap server name localhost 9092 option, and subscribe topic is orders dot load. When it comes to customers, here we use materialized view, return spark dot read dot format CSV, option header equal to 2. If we have header, we can make header equal to and load. Here is the location of the customer's CSV. Here is a materialized view of customers underscore orders. Here we specify the joining strategy, spark dot table dot customers, customer ID dot select. Here we select the required fields. Here we have spark-pipeline.yaml file. Here is the name of the pipeline. Here we mention the libraries. Which folder is considered as a root folder. Here we consider transformations as a root folder. Storage. Here we specify the checkpoints in my pipeline. When it comes to the catalog, we mention the catalog name, database name, and configuration. If in configuration we mostly specify the partitions, how many partitions we need. Here we mention 1000. Spec fields, library. What are the required fields we need to create a Spark pipeline? Here is we must need libraries. Storage, we optionally need data, schema, catalog, and configuration. Here how Spark HTTP looks like, root directory, and Spark pipeline.yaml file, and we have transformation folder. Here we have ingestion.py, transformations.py, aggregation.py. When it comes to testing, we done unit testing on our code. Here test_transformation.py. Here we have some project tips. Name specific file spark-pipeline.yaml file, conventional. Spark pipeline runs auto search parent directory for specific. mix.py.sql files freely in the same folder. Use Spark pipeline dry run to. Here is a summary. Spark declarative pipeline. What? HDP is a declarative framework introduced in Spark 4.1.1. Define dataset. It's 3 types: streaming table, incremental, materialized view, batch pre-processing, temporary view, pipeline scope, flows, core processing units, read a source, apply logic, write to target, auto orchestrate by HDP, APIs, Spark.python module, and SQL.sql files, both are first class. Mix freely. CLI, Spark pipelines init, run, dry run, build on Spark submits, support all cluster management. Avoid. Never call, collect, count, save, start, etc. inside a dataset function. Keep them